discuss about three important rules while we have to remember while writing electronic configuration of an atom. The first one is Pauli's exclusion principle. So this Pauli's exclusion principle was explained by Wolfgang Pauli. He is an Austrian physicist. That's why the name of this rule is based on Pauli. That means Pauli's exclusion principle. Now let us try to understand what this principle says. What are the important points that we need to remember from this principle? See, the Pauli's principle explains about the occupancy of electrons. That means, in that last class we have discussed about the orbitals and also suborbitals. In each suborbital, how many electrons can occupy? So this rule explains this occupancy of orbitals. So let us try to understand one in detail. So first, we know that, let us take an example, helium. So the atomic number of the atom helium is 2. That means there are 2 electrons in helium atom. And where these 2 electrons are, let us try to understand. And this helium, it has 2 electrons and it has only one shell, that is 1s shell. In this 1s shell, the 2 electrons, one in the while we are discussing the spin quantum number, we have discussed that electrons can have 2 possible directions. That means electron can move in 2 possible directions. One is clockwise direction and another one is anti-clockwise direction. We have also discussed the values of spin quantum number, that is ms. If it is in clockwise direction, its value is plus half. If it is in anti-clockwise direction, its value is minus half. So here, helium contains 2 electrons. The first electron, we can take it in the clockwise direction. If we go to the second electron, and how it will be, where it will be? The second electron will be in the opposite direction of the first electron. That means in anti-clockwise direction. So each suborbital or each degenerate orbital can have place for 2 electrons. So by this Pauli's principle, we can say that each degenerate orbital can have place for 2 electrons. So it explains the 2 electrons of a suborbital. And one more important point that we need to remember in Pauli's exclusion principle is, so if we take any atom, so any 2 electrons of that atom should not have same quantum numbers. That means no 2 electrons in an atom should not have same quantum numbers. How it is possible? Let us try to understand this with an example. Let us take carbon atom. The carbon atom, its atomic number is 6. That means carbon atom has 6 electrons. Where these 6 electrons are, let us try to understand. So this is 1s orbital. So from these 6 electrons, so 2 electrons can be occupied by 1s orbital, and then 2 more electrons will be occupied by 2s orbital, and this is 2p orbital. This is px, this is py, this is pz. So 2 plus 2, 4 electrons already filled here. So we have 2 more electrons. and these are the two more electrons. And now let us try to write the quantum numbers for any two electrons. Let us take the first electron, this electron. So we have four quantum numbers, that is, first one is principal quantum number, the second one is angular momentum quantum number, the third one is magnetic quantum number, fourth one is spin quantum number. Let us try to write the four quantum number values for first electron. So this first electron is present in 1s orbital. So the principal quantum number value will be 1 here. And what is the L value? So this electron is present in s orbital, and we know that for s orbital the L value is 0. Let us come to ML value, that is magnetic quantum number. To find this, we need to know that is a simple formula, that is 2L plus 1. If L is equals to 0, substituting the value of L here, we get 1. That means ML will get only one value. So that one value is 0 here. And now spin quantum number value. So this electron is in clockwise direction. So its spin value will be plus half. So these are the four quantum number values for this first electron. Now let us take the fourth electron, this electron. Now we are going to write the four quantum number values for fourth electron of carbon. First, the principal quantum number value. So this fourth electron is present in second shell, that is in 2s orbital. So the principal quantum number will be 2 here. What is L value? So this electron is in s orbital. So the L value for s orbital is 0. And now ML value same remains like this. If we substitute 0 in this formula, we get 1. So that one value is 0 here. What about spin quantum number? This electron is in anti-clockwise direction. So that's why its spin value is minus half. So you observe carefully the quantum numbers for first and fourth electron. So the principal quantum number value is different here, and these two are same, that is also different. Like that, if you write quantum numbers for any two electrons in a same atom, so the four quantum number values are not same for the two electrons. Even a single quantum number value may be changed. So this is explained by the Pauli's exclusion principle. So finally, two important points that we need to remember from this principle is the first one. This explains about the two electrons of an orbital. That means a suborbital can contain only two electrons. And the second point that we need to remember is, note the four quantum numbers are not same for any two electrons of the same atom. So these are the points that we need to remember in this Pauli's exclusion principle. So in the next class, we will discuss about half-bow principle.